When you first start to learn programming, one of the first concepts you have to learn is the concept of variables. And so in this presentation, we're going to talk about what variables are and why we need them. We'll talk about primitive data types. We'll talk about how to declare variables, and this includes legal variable names and legal values that we can assign to variables. We'll talk about how to give a starting value to these variables, and then we'll finish off by looking at some of the operators that are available to us in Java, including Java shortcuts. So what is a variable? Well, we know that computer programs have to manipulate data in some way. That's its purpose. And so we have to store this data somewhere. So a variable really represents a named cell in the computer's memory, and it's going to be used to hold information. So when we declare a variable, what we're really saying is that we want to open up a chunk of the computer's memory, and then we want to give it a name, which in computer science we call it an identifier. Okay? Realize one of the common mistakes that beginners make is that they try to do this multiple times, but we really only have to do this once per variable that we're trying to create. So one of the first things that we have to talk about when we're talking about variables is the concept of data types. And a data type describes the kind of information that we can put into a variable. Now realize that some of these data types are built into the language, and an example of this would be an int or a float in Java. And then sometimes a little bit later on we can define data types for ourselves, and this is going to push us into the concept of object-oriented programming. So we have different forms of data types. We have primitive data types, and those are the ones that we just talked about, such as an int or a float or a char. And then we have complex data types that we usually make ourselves, but they're comprised of a series of primitive data or other complex data types. And don't worry about that now, we'll get into that a little bit later on. So looking at the primitive data types, these are the simplest kinds of data types. We really can't break them down into other forms of data types, let's say. A lot of these are built into Java, and here's a couple of examples that you would see in blue here. The first one would be a byte, and a byte is 1 byte big, hence the name byte, and it has a really limited range. It has a range of -128 to +127. The next larger data type for whole numbers is a short, and this is made up of 2 bytes typically. It has a range of -32,768 to +32,000 more or less. The next larger data type is an int, and this is typically comprised of 4 bytes. This gives us a much larger range. In fact, it gives us a range of about -2 billion to +2 billion. And then finally, a really large number range would be something like a long, and again, this is a whole number, and it has a range of -2 to the 64 to 2 to the 64, which is about a 20-digit number. So that's a really large number. We really don't use those very often because they do take up a little bit more memory. Most often we use an int because it has a good range and it only takes up 4 bytes. So we also have some other primitive data types that are built into Java. We have decimal numbers, and those include floats and doubles. A float is less precise than a double because it only has 4 bytes versus a double which actually has 8 bytes. And when we talk about precision, we're really talking about the number of numbers that come after the decimal point. There are a couple of other primitive data types in Java, such as the char. And a char, notice that it has examples here, and they have the single quotes right here. So you have the single quote A, single quote. We could also have an uppercase A that's perfectly legitimate. And we also have the single quote 1. Realize that that's not a number, that is the character 1. So it's slightly different. And then this example that we have right here, it's actually a space. Okay, another example of primitive data type would be a Boolean. And this holds a value of exactly true or false. And it's actually only 1 bit big. Now, something that's not a primitive data type that we're going to be working with quite a lot is the string data type. And this is built into the language also, and it begins with a capital S. So remember when you're trying to create a string a little bit later on that you want to have a capital S because Java is case sensitive. What is a string? A string can hold a series of characters. And there's a couple of ways to do this, but the string is the most common way to do it. So how do we declare a variable? Whenever we want to open up a chunk of memory, we're going to use this format that you see right here. It's going to be the data type that we want, and we have to give the variable some kind of identifier or a variable name, followed by a semicolon here on the end. And remember, semicolons, you're going to get a little bit confused when you first get into it, but a semicolon is at the end of a single statement. And that'll make more sense as time goes on. Okay? For a variable name, you can choose just about anything that you want. There are some restrictions, such as you can't have spaces in your variable names because then the computer thinks that it's 2 words. You can have underscores and things like that, but read the book for a little bit more information about what's legal and what's not. So let's see a couple of examples using this format that we just talked about. Here are 4 that you see right here. Notice that we go back to the format of data type variable name semicolon, and so you can see here the data type would be a byte. So remember, that's the really limited -128 to +127. There's our data type. The variable name is called age, and then we put a semicolon at the end. Now what's going on, and you can see computer's memory over here, we've opened up a chunk of memory that we don't have a starting value in, that's why the question mark is here, but we have opened up this chunk of memory and called it age. A couple of other examples here. Here's the data type variable name semicolon, in other words float GPA semicolon. Here's another example, string name semicolon. And then here's a final example, char letter grade semicolon. But notice in all 4 of these examples that we can go back to this format of data type variable name semicolon. Okay, so now that they're declared, we don't have to tell the computer twice. We don't have to redeclare these variables. Later on, we can also refer to them just by their name. In other words, age, GPA name, or letter grade. Okay, some other things that we have to be aware of is that there are reserved words in Java, and a reserved word is something that's kind of held onto by the language of Java. When you see the ones down here in blue, these are used very often, and red is reserved, meaning that it's still part of the language, but it's not really used. And so you can see, I think there may be about 50 of them down here that you have to be really careful. We can't use these things as a variable name. So looking at legal variable names, first of all, it can't be a reserved word. It can't begin with a number, and be careful on that. It can't contain special symbols like the pound sign, the @ sign, exclamation, and so on, or spaces. There are exceptions to this rule, though. You can use the underscore, and you can also use the $sign. So let's look at a couple of examples here. Again, following the format of data type variable name semicolon, you can see we've got a byte right here as our data type. This is going to be legal because we can use the $sign according to the rule set. $sign the value semicolon. So this would be a legal version of a variable name. And notice that I put a comment here with these 2 slashes that says it's legal. Okay, char test value. Again, this doesn't really break the rules because we're just using the underscore. So it's data type variable name semicolon. If we go down here and look at double, remember that double is a reserved word, so we broke that rule. So this is not legal. Going down here to the 4th one, you have int that is the data type, but then rum and coke. An example of breaking the rules here, we can't use the ampersand, so that one breaks that rule. And then coming down here, you could say Boolean, true or false. This actually breaks 2 different rules, and maybe I'll leave it up to you to figure out what those 2 are. So looking at literal values, these are things that are constant, and I think it's best to describe these things with examples. Here are a few of them right here. So we could have the literal string hello world. This value here is not going to change at all. And I know that it's a string because it has double quotes instead of single quotes like we have for a character. Okay, here's an example of a literal value 17. It is a whole number 17. It's not going to change. It's always 17. Here's a literal decimal number, 3.14159. And then finally, we have a literal character with V. And again, notice that it's a single quote instead of a double quote. If it was a double quote, that would be string. All right, so when we hear the term initializing a variable, this means to give it some kind of a starting value. And to do this, we use one of the built-in Java operators, which is the equal sign. But I'm going to say that this is gets, because it's really not the equal sign in terms of equality. We'll explore that a little bit later on. All right, so what's going to go on when we use this operator is that we're copying the information on the right side into the variable that's on the left side of this when we're talking about the code. And the things that we can copy over can either be one of these literal values like we saw just before, like a 17 or a 3.1419, or it could be the value of another variable. So let's see an example of this. Looking down here, you can see that I declare a variable called age that's of type int. So int age semicolon, following that format. And then I'm going to copy the value 15 into age. So what we've done with these 2 lines is to open up a chunk of memory and put the value 15 into it and call that chunk of memory age. Okay? Looking at another example, char letter grade gets assigned the value b, the literal value b. So again, I've done a one-shot deal, 1 line of code that opens up a chunk of memory, calls it letter grade, and gives the initial starting value of b in that chunk of memory. And then we might do some other kind of thing just to show you how we can copy another variable into another one. I might say something like this: char your grade, right? So we're creating a new variable here, gets the value of letter grade. So the end result of this is that because letter grade is B, I'm going to copy that into the variable your grade. Okay, so let's take a look at some of the different data types and why they're important. Remember that when we declare a variable, we're opening up a chunk of memory, but the question is how big? And we saw some of that before where we had 1 byte or 2 bytes, 4 bytes, 8 bytes, something along those lines. Realize that you can't put a larger data type variable into a smaller data typed variable. So look at what's legal and why it's legal and then what's illegal. It'll make sense. Okay, so we might say something like byte B gets a 5. We copy the literal value 5 into our byte B. You can see that down here, and then we create a long, which is 8 bytes, called L, and then we take the value from B and put it into L. So if we wanted to visualize this, you can see that it's because we have 1 byte big here, we can easily fit that into a long, which is 8 bytes. So if we were going to put that into it, you can see it fits just fine. Now conversely, if we try to say long L gets 5, and then we put that long into the byte, it's not going to fit. Now, is it going to error out? No. But some of the data that was in the long could potentially be lost when we move that over to the byte. Okay, so kind of finishing out this lecture, one of the other things that you need to know about Java is the operators that are built into it. Most of these should be fairly straightforward. We have the plus sign, which is the way that we have addition in Java, so we're going to add two variables or literal values together. Okay, we can also do this with strings if we can concatenate those two things together, which is kind of cool. Okay, here's how we do subtraction. That's the minus sign. Division is the division sign, or the forward slash. The star is multiplication. And then a new one for a lot of folks is the modulus operator, which is this percent sign. And you have to kind of go back into earlier math. You probably remember these things as the remainder after division. Okay, and I think we'll see an example down here in just a minute. Okay. Also realize that we do have mathematical precedence by using the parentheses here, so it follows standard math rules. So here's an example. If we were to look at this line of code right here and figure out what needs to go into result, out of all of this mess, where do we start? Well, we're going to start on the innermost set of parentheses. So looking at 4 modulus 3, remember we're trying to figure out what 4 divided by 3 is, which would be 1, but it has a remainder of 1. So this result right here is going to give us 1 times 5. That's the next set of operations. So it's 1 times 5 gives us 5. And then finally we finish it out with the plus 1. So we're going to take the value 6 and copy it into result. Now realize one of the things that I've seen especially new programmers do is they try to increase the value of result, let's say by 1. And what they would code would be just result plus 1. Understand that this doesn't really change the value of result. It does resolve to result plus 1, but it doesn't update the value of result. So in other words, it's not going to change the value of result as an operation. All right, let's look at a code trace. And so we'll just walk through this code. There is some code missing, but it's okay. We can still walk through it. Okay, so in this first line, what's going to happen? Well, we'll have short value 1, semicolon. And again, it follows that format that we talked about before. And we've opened up a chunk of computer's memory right here called value 1. A little bit later on, we open up an int, and notice that an int is bigger. It takes up a little bit more computer space. So we call this one value 2, and it is of type int. When I say the next line down here, value 1 gets 5, then we're taking the value 5, copying it here into value 1, and then we do something a little bit more complex here. We're going to assign a value to value 2. So we take the old value 1 right here, 5, we add 9 to it, and that resolves to 14, and then we copy the 14 here into value 2. And that's literally what's going on in the computer's memory. All right, finally, we need to look at some shortcuts that you're going to see very often in Java and other languages like C and C++ and maybe C#. The first one is the plus plus operator. And there's a couple different versions of this, and I'll give you an example of that maybe in a later tutorial. But often you're going to see that plus plus will follow a variable. And what do we mean by this? Well, if you see int counter gets 5, it's going to start out with the value of 5. So we open up a chunk of computer memory called counter and stick a 5 into it. And if I say counter plus plus, this is the shortcut operator. It's the same thing as saying counter gets counter plus 1. Now what does this mean? I'm going to take the current value of counter, which is 5, going to add 1 to it and get the value 6, and then copy that back into counter. So essentially, I'm updating counter by the value of 1. Now, similar to that, we have a plus equals operator. And this is going to modify a variable by a certain amount. And it can be positive and it can be negative. It doesn't really matter. But anyway, let's look at the example here. Int counter gets 5, semicolon. So I've got this variable counter. And then when I say counter plus equals 3, that's the same thing as saying counter gets counter plus 3. Now what's going on here is we take the value of counter, which is currently 5, we add 3 to it. That gives us the value of 8, and then we update our variable counter with the value of 8. So these operators are actually modifying the value that's within that variable. As a final note here, also notice that we have minus minus operators, just like we had plus plus operators. Minus equals, mod equals, div equals. So there's a couple of different versions, and there's also times equals there too that should be listed here as well. Okay, so when we're talking about different data types, if you go back to a previous slide where we talked about trying to put a long into a byte, we said that's not really possible, or if you do it, you're going to lose precision. When you know that that's going to happen and you say, fine, I'm willing to take the consequences, you can do something called typecasting. And this is when we're trying to change temporarily the data type of a variable so that we can do this assignment of something really large and put it into something small. It has this very bizarre looking kind of format, but we have a larger variable here over on the right, and then in a set of parentheses we have the data type of the smaller thing that we're trying to go to. So let's see an example of that. I think it'll make a little bit more sense that way. So let's say that I have long, my long gets 17, so we copy the value of 17 into my long, and then I want to put that here into my byte. Well, we know that a long doesn't really fit into a byte. So what are we going to do? Well, I'll say I'm going to typecast my long into a byte, right? You can see the byte within the parentheses here. Take the value, whatever the byte value equivalent of my long would be, and put it here into the variable my byte. So essentially what we're doing is we're squeezing my long into my byte, even though we know that we're going to lose some possible data when we do that. All right, so one final note, and this gets new programmers into trouble, is that by default a decimal is a double. Okay, so here's something that won't work, and it's exactly related to this typecasting that we were just talking about. What data type is 7.4? Well, according to this rule, 7.4 is a double. So you could say float, my float gets 7.4, and the computer would say, hey, you can't do that. You're trying to put a double into my float. So in this case, we have to typecast it, and one way that you could do it is to say float, my float gets a float version of 7.4. Another way that is acceptable is you could say float, my float gets 7.4 and then put an F right here before the semicolon right here. This way takes a little bit longer, but it makes more sense with the previous slide that we just talked about. So that's it for now, and I'll see you in the next tutorial.